We are going to approach the most important topic of this class soon, which is derivatives. Maybe you know it, maybe not, but average rate of change is right before that topic, right before defining the derivative. And the formula is in front of you. Maybe I should just lift it somehow. Is it blinking again? I wonder why. Okay, maybe it stopped. Maybe I should not click too many things and then it's doing fine. Now it got crazier. So, the average rate of change of the function, let's write down. The average rate of change, ARC. That is not international notation, that's an English notation, but it's fine. Average rate of change of a function of, now you have a disco party. It got much worse. But it was fine when I came, right? So, what is your problem? It's supposed to be a modern building with good technology. Okay. Hopefully it's fine. Of a function f of x over the interval, usually called I, because it's interval, closed interval a and b is. And now there's a formula, it's above, and now I can rewrite it again. Change in output over change in input.
Sorry, can I go back to the
Yeah,
base formula?
that is the idea here. Change in output. You keep sitting farther and farther. It's so funny. How you're relocating back.
Just trying to help.
Find the best seat. That is smart, yes. And try to go all around the place. So if you don't hear me well, definitely move to the front. But don't sit over there. You see, you have disco party there. Sometimes. Hope you don't have epilepsy from this. But change in y over change in x. You see, f of b minus f of a over b minus a. Next one minus previous one. We always do that. I'm walking from here to home. How long did I walk? I do this second point, which is home, minus this point, which is the initial point. So that intuitionally, it makes sense, intuitively, right? So let's see the graph. Just a random function. Let me draw a random function. Usually we lose something like so. And then we're asking, what was the average rate of change from A to B, including endpoints, so like so. On this graph of the function, what? Yeah, I is interval. That's also international notation, very nice. So, yeah. The average rate of change is like on average how much they change. So if your exam grades are like 75, 85, 32, and then the final exam is 95, what was the average exam grade? We kind of know how to do it. You add up, divide by the number. But what if it's not a number of exams? What if it's the interval? And that's why we're dividing by the length of the interval. So it's kind of the same thing as with exams. So if the formula says take f of b, that means I need to find the height of the endpoint, right endpoint, right? So like so. That is my f of b over here. And I'm putting this point on the graph. Then it says take f of a. Here it is. F of a. Find the difference. And then divide by the length of the interval. That is b minus a. So let me put it in green, b minus a. And this is f of b minus f of a. So we're taking difference over the difference. Change in rise over change in run. That's the idea. What it means is we are drawing a line between these 2 points or through these 2 points with the slope, which is going to be f of b minus f of a over b minus a. That's exactly the formula of the slope. So the slope of the line, of this line, is exactly like I told you. Change in output, let's call it y, over change in input, let's call it x. So it's exactly what we're talking about. So those two definitions match. The slope of the line will match with the average rate of change, say, of your grades. So that's kind of the idea here, which is f of b minus f of a over b minus a. Do you remember what slope is? If you don't remember y equals mx plus b, m is a slope. But intuitively, slope is how steep your hike is. So I'm hiking the mountain. If the slope is like so, it's not very steep. I'm hiking fine. If the slope is like this, I'm already climbing. If slope is like this, I need special equipment to climb the mountain. If slope is 0, that's a floor, so it's not a hike anymore. It's just a walk. So steepness is a slope. That's exactly what they mean here. Now, example, and I will show you some nice animations today. Example 4 f of x, probably 4 should be capital, f of x, let's choose x squared plus 1. Let's find the average rate of change, arc, just easy to write down, of f, the given function, of x over the interval 1 and 3. So we're telling you where to look. It's like, for example, you're paying utilities from January till January, but I only want to know how much did I spend this summer for AC. So the interval will be shrinked from May to September, and that's a lot of money. That's the idea. And on interval, so there are 2 different intervals. Let's do that. That's called A and B. So solution A. So over the first interval 1 and 3. First of all, x squared plus 1 is a parabola. If you remember, I sent you the YouTube video about basic graphs. You kind of need to imagine what is happening here. The normal parabola looks like this. That is x squared. X squared plus 1 shifted up by 1 unit. So it will be like this. Over 1 and 3, it's over here. I will make it blue from here to here. So we're asking how, on average, the graph changed from 1 to 3. We're just following the same steps I did over here. I need to find all those points, but not graphically. In this case, I can do it by just plugging into the function. But I can do it graphically if you want. Find f of 1, it's over here. F of 1. Find f of 3, it's over here. And then build the equation. I was seeing there was a question. Yeah.
Shouldn't the graph slope up a bit more because 1 squared plus 1 is 2?
Yeah, definitely. I just did not really care too much.
Oh, sorry.
He means like it should be a little bit higher, but I just did not care. Yeah. Let's call the sketch. Let's call the sketch of the graph. Yeah. Then you have to accept it as a sketch. But and that is why, because I'm not going to use graphically those numbers, I will plug them into the equation. So I will find f of 3 and f of 1, and then find the difference, and then divide by 3 minus 1. F of 3 is 3 squared plus 1. F of 1 is 1 squared plus 1. 1 gives me 9 plus 1, which is 10. The other one is just 2. So the formula tells me that I need to take that, subtract the second point, minus the previous one. That makes sense. You don't have to memorize it. It just makes sense. You do the second one minus the previous one. How much did I spend for AC for those 3 months is I take September minus June or May. So always the next one minus the previous one. Over 3 minus 1. That is the length of the interval. Also makes sense. So the average amount of, what was the average change of me paying the AC? I take the last amount of money I paid, say it was $200, minus the first one when it was not too hot in May, say $150. And then I'm dividing by the number of months. That is your average. That's how you find average of your tests, right? You're dividing by number of tests you had from 0 to 4, if you have 4 exams, for example. So that kind of makes sense. 10 minus 2 over 1, which is, what is that?
Over 2.
4. Is it 4?
Yeah.
Yes. Good job.
That has to be
No?
over 2, not over 1.
Over 2. Thank you. Yes. I was like, why it's not looking right? Good job. Well, I always make mistakes on purpose to make sure you pay attention. Now, so this is going to be my arc. Average rate of change on this interval. Now, who wants to do B? B over, what was the other one? 1 and 2. I will do arc. Who wants to plug the numbers for me right away? First of all, the denominator is different or not? What is it? 2 minus 1. That's the one I see right away. The moment I see 1 and 2, that is my interval I need to have in the denominator, a difference change in x. What is going to be in the numerator? F of 2, what is that?
5.
5. And then f of 1, we already have it? 2. So the answer is 3. Too fast, or you're fine? What do you think? Same idea, I just found really fast f. Well, you helped me, so now I know. And this is exactly what we did here. We draw a line through those 2 points, found the slope of this line using the famous difference slope, m usually it's called, which is f of x2, the next one, minus f of x1, the previous one, over x2 minus x1. You don't have to write it down because I actually have it here. This is all different formats of the same writing, y2 minus y1 over x2 minus x1, f of b minus f of a minus b over a, f of x2, that's a new x, minus old x over new x minus old x. And the shortcut is delta. Delta is a triangle. Delta means change. Change in y over change in x. Usually means small change. Sometimes it means a step size, like in computer science. So all of these are the same thing. You will see them in literature. Which one would you like more? I don't like the last one, too much writing. I like the first two. The first two are short and convenient. So that is also interesting. Sometimes in your homework you will see a table. So I mentioned before, and I will mention right now again, there's 3 ways to, actually more than 3, but usually we give you 3 ways of seeing a function. A function can be written as x squared plus 1. That is an expression, right? We do equations, we solve, and so on. A function can be given in form of the graph. That's also one of the ways. Sometimes we have both, sometimes we have only one. But sometimes we don't have any of these. What if you're a data scientist or actually working in the lab? You were sent to get some data. You went to the highway, you put a device with the speedometer, and you're like, every 5 seconds you have some kind of recording of the speed. Now you end up to be with a table. It has x and y and, let's say, t, time, numbers of seconds, 5, 10, 15, and then you stay there for the whole hour. And then speed, 75 miles an hour, 80, 65 of different cars. Then it's a table. We need to learn how to work with all of this. Specifically, if you're going to do some medical or sciences, you will be working with lots of tables. Even I was working with lots of tables on patients' data. Patients were recorded how many times the nurse was interacting with the patient to see if the nurse is sick. How many patients will get sick from the nurse? That's what they call it. A nurse is a super spreader. So they put a device in the nurse, and every time she would stay longer than 1 second, the device would record it. So I saw huge Excel tables with 30,000 lines and 15 columns, and you need to learn how to scroll and look at all of this. And if you actually get a job in data science, that's going to be your daily routine, and you will pay 6 digits just for the scrolling and looking at it and seeing meanings behind those numbers. So that was pretty cool. That's what I do for my honors projects if you want to do that. It's pretty interesting. So what if you do have a table? You don't have to copy, I don't know, just you can have my notes later, so you don't have to copy it. But if you do, here it is. The table shows the distance traveled by a car. You see, t seconds after it starts moving on a straight road. We don't have a graph. We don't have expression for the function. We have a data. It was collected. Still, you need to know how to find derivatives, average rate of change, and so on. Find the average velocity. Average change of distance is velocity of the car from T4 to T9. I'll wait for you. And now you look at this, and that's why I don't want you to look at this in this like typical student mindset. Oh, we never did this in class. Yeah, try to fight this scaredness of seeing something new. It's okay. You never seen a table before. Now you do. The idea is still the same. This on the left is my input, which we usually call x, but in this case it's time t. This is my output, which we usually call f of x, but now it's d of t because it's distance. That is d. D in feet and t in seconds. So the car was traveling. When it was started, it was 0 distance, then in feet. At 1 watt second, 10 feet, 2, 14.1, and so on. In 10 seconds, it's already past 31.6 feet mark. They ask us to only work from 4 to 9. They don't care about 0 and stuff. So we're gonna do from 4 to 9, like so. And now you're just really creating a formula, and the work we did before is already done for you. Before we had to take the input, plug it into the expression or a graph, find the output, and then build the formula. Everything is done for you here. So actually this is much better example for the exam because it's faster. So the formula is arc is change in output, it's called D, of T2 minus change, second minus the first, over change in input, or the length of the interval. Denominator is the length of the interval. So, denominator is easy to create. What is that? You just look at this. Yeah, but what is... immediately when you see those T and T, that's what they call T1, T2. What is denominator?
5.
Yeah, but how did you get it? 9 minus 4, thank you. And then you don't have to think too much right now. You just plug it into D in the same order. So if you first create denominator, it tells you what the numerator is. And now you have to go and plug it into your function. In this case, it's already plugged in. Do you understand why I'm saying that it's already plugged in? Because the second row of my output, see, I don't have a graph, I don't have a function given, but I have data. The second line already tells me at 7 it was 26.5, at 8, 28.3. I need at 9 and at 4. So what are the numbers for the numerator?
10.
Yeah, but how did you get it? Don't skip the steps. I already can see who will lose points for not showing work on the test. Don't skip the steps. So 30 minus 20, how did you get it? It was here, right? Input versus output. Input versus output. 9 and 4 are inputs. 30 and 20 are outputs. Which is 10 over 5. Which is 2 units? Who knows? Engineers usually always ask me, what are the units? And I have to always write it down. What are the units? Feet per second, thank you. First of all, it's speed. So we are asked to find velocity. Velocity is definitely per. Remember, it's like miles per hour and so on. Second of all, it's coming from literally the fraction. The top is in feet, so it's over here, feet. And the bottom is in seconds. So it's literally there. That's why it's feet per second. So that's one of the applications. And let me finish, see if you're done. Well, I'm judging based on the front row. So if they are done, you all should be done writing. If you want to see real applications of this, then definitely I can see the coordinator. She had a very nice idea of collecting the COVID cases. Probably it was a year ago, and this is exactly what data looks like, right? That you go and you collect the data, and then how would you find the average change from this date to this date? You literally Let me do a snip tool of this. You literally do what we just did. You find the first input and the last input. Take the difference of these. That is going to be dates, right? So it's in the same months. Actually, it's 7 months and 8 months. So how many days is that? Then you take second output minus first output. And that's how you also find the average change. So it's literally exactly what we just did. So it has lots of applications. I'm just trying to tell you that this has lots of cool applications. And this is exactly the formula over here. How many cases minus how many cases? Over 30. If the number is negative, what does it mean? Declining. Because again, we're finding the slope. If the slope is negative, what kind of hike I'm having if there's a negative slope of the mountain? I'm hiking down. Same with number of cases, same of the population of deers in Tempe. Do we have deers here? I don't know. So it's declining. We're probably killing deers. We should not. And that's kind of the idea here. Slope shows a lot of information. The number of it, the sign of it, all of this is important. More stuff. So alternative notation. Alternative notation for arc, average rate of change. Different notation. So we just learned, I just gave you 3 different notations, and I'll give you one more right now, but it's completely different, very interesting. We learned f of b minus f of a over b minus a on the interval from a to b. More scientifically correct will be to call this interval x, and then the next one, we're not going to call it x2 or something. Some people do call it x1 and x2, but if they want to indicate that it just was a step size from here to here, from a to b is h, then the next point will be x plus h. If it's to the left, x minus h. So if I change, if a is x and then b is x plus h, where h, so that is a picture, where h is the small change. Usually h is not in millions, unless you're talking about space science and stuff. Usually h is a small change, like 5 seconds, or 3 meters, or 2 people, I don't want to say 2 people died, that's going to be very negative to say, but some small change. So, couple, something a little bit. Then, what? Then I plug it in. I'll keep it like so for now. I plug it in. Did you get it? Yeah?
Well, because I got the only thing that was going to be in the Bible.
Oh, you wanted this one?
No.
Yeah, here it is. Then I will have f of x plus h. Remember the next one. Minus f of x all over. And in denominator will be x plus h. That's h. Minus x, which is just h. And it is a very nice short notation that becomes f of x plus h. That means output of a little of change. So f of x plus small change minus the original output over the interval, which is that small change. So x canceled out. This expression is called difference quotient. Difference quotient. And that is important. That is more popular because step size is important. If you ever do computer science, if you ever learn how to code, and maybe you're doing it right now, you will see that in your code, Java, C++, whatever you do, Python, you actually need to indicate step size, usually, or I, counter. I is 1 or 0.5. That is exactly what h is. It's a small step size. Usually you make it small, and soon we're going to learn how to shrink it to very small, to infinitely small. So h, it's kind of a step size, but let's call it small change. Small change. Let's practice finding that. And now we're going to do more algebra. If he was not in the mood doing some algebra today, you will get to do algebra. Example. And this is what we like to put on the first exam. Specifically, this example is actually really good. For the given function f of x, which is 4 over x, a fraction, of course, find a difference quotient. And, find the difference quotient. Find a difference quotient. So we know the formula. It will be a little bit challenging to do it right away, like so. So I usually suggest to do it in steps. But the goal is to build the formula. F of x plus small change h minus f of x over h. We want to build this. Because of the fraction, it will be hard to do it right away. And I'll show you right now. So, let me actually do it step by step. Yes?
Why does it matter that h is small? Wouldn't it be the same either way?
Yeah, that's a very good deep question. Why matters that h is small? The smaller step size, the more precise your model. For example, you are checking how many people got COVID. Would you like to check it on January and next time in May, or actually every day? So the smaller step size, the more accurate your model. You don't want to see.
So it's to make the average change and make it meaningful.
Exactly.
It's kind of that technically it's true no matter how big h is.
Yeah.
But in some cases it's not.
Exactly. And some people actually manipulate statistics in the news saying, statistics says most women, they like pink color. And then you check the study and it says, we asked 3 people. So the step size is horrible, right?
I see what you're saying.
Yeah.
It's that you could do it with h aiding anything, but it would be misleading.
Yeah, exactly. And some people actually do use it on purpose to kind of change. Statistics is exactly based on this idea. How big is the step size and what is going on? Soon we're gonna show you how to manually shrink step size to so small that it's almost precise. So in steps, step 1, let's first find the f of x plus h. And this is where I need to teach you or maybe remind you how to do that. So we have f of x. So pay very much attention right now. At least right now you have to wake up. You see x is the input. The output says 4 is divided by that input. So from now on I will be calling f of input equals 4 over input. That is important. So if now my input changed, literally it has a change in it. X plus h is my new input. I will have to follow the rule. The rule says 4 over new input. New input is x plus h. Does it make sense what I just did? That I think is the most confusing thing for students. And I usually make it like side example about love. Side example. If in the same example I want to calculate how much love they are in this function. So I want to find f of love. That doesn't matter. If that input is in the domain, I can do that. It's going to have the same law. It's going to be 4 over love. Does it make sense? So whatever I'm telling you to plug in, you should carefully go locate all the inputs in the equation and substitute them. You know the function in Excel, search and change, replace, search and replace. You're searching for x, replacing with love. You're searching for x, replacing with x plus h. If I ask you to find f of sine 3x squared over 2, then guess what? It's going to be 4 over sine of 3x squared over 2. Make sense? So copy paste. That's the idea. That is a very crucial idea to know. Without it, you will not be able to do many things. So We have f of x plus h. 2. Let's find f of x plus h minus f of x. 4 over x plus h minus the original one, 4 over x. Who remembers what kind of suggestion I gave you last time when it comes to fractions? I gave you a suggestion last time on Friday. If you see many fractions, what do? You make it 1. That always works. You see 2, 3, 5 fractions, probably it's easier to make 1 fraction. So let's do that. Common denominator, x times x plus h. My notation, you don't have to follow it. I'm multiplying by x here, multiplying by x plus h here. That are the missing factors of the common denominator. Then the first fraction will be 4 times x. And the next one will be minus 4 times x plus h. Don't lose the negative sign and don't lose parentheses. I will stop for a second. What do you think? Does it make sense? Moment of silence, and then we simplify. Do not touch the denominator. Keep it as it is. It's like so. The numerator can be simplified. 4x minus 4x plus 4h. Correct or not?
No,
What is the mistake?
it's minus 4x.
Minus. Make sure you remember this. This is important. This distribution sign will cost you everything. It will cost you everything if you want to be dramatic. So be careful with this. This is a very common mistake I see. And now, at the moment of truth, 4x minus 4x goes away, and you end up to have negative 4h, exactly, over x times x plus h, like so. Why we're doing all of this, I don't remember. Who remembers? We're building this formula. So we just did the numerator. Now we need to divide by h. So that is step 3. When you are done, step 2 is the most tedious one. Step 3, I'm taking this in black, well, minus 4h, x plus h, and dividing it by h. Because that's what the formula says, divide by h. But just like I mentioned to you last time, oh, actually, yeah, I can see. Interesting. I forgot to divide by h. Last time I mentioned to you, dividing and dividing means you get this h and put it here. So the answer will be minus 4h over x times x plus h times h. Do you all agree? If you're dividing over x times x plus h, and then you're dividing by h just join the denominator. That's kind of how I see it. Or you're multiplying by the reciprocal of the fraction, and the fraction is h, so 1 over h will be a product. What is the last step? The h goes away, exactly. So the final answer is just this, minus 4 over x plus h. And now, this is what they call a difference quotient. Why it is important to find this? To torture American students on a test. That's the first reason. And to be honest, that's true. I actually did not do any of this. When I was a student, it's a local thing. They like students here to find difference quotient a lot. And the second reason is, I'll answer the question. The h which you ask why it's supposed to be small and so on. When you're in computer science, biomedical sciences, biology sciences, you then change the h. So you're like, wow, I can see for zebrafish, that's h, the step size will be 1 day. You came back in 1 day to your lab, and now you see that they have 3 times more population. You're like, okay, 1 day was a bit too much. Let's change h to be to 14 hours. Now you come every 14 hours. Still too big. You want to see what's happening every 5 hours. So you will be changing h, and that's why h is an important variable. Even though when they are mentioned, if it's a constant or a variable, h will be that running dummy variable, that's how we call it in computer science, which you will be able to change. So that's pretty cool for lab or in general for science, it's nice to have that variable not fixed as a number. Let's not have h as a step size 5 kilometers. Let me, as a scientist, choose h in the future. That's why this equation is pretty good. Yes?
For step 3, why did you divide everything by h?
Yeah, that's a good one. I was wondering if anyone asked this question. So the original formula is this. So when I finished working with the numerator, that was step 1 and step 2. And then I was like, what are we even doing here? Oh, we were supposed to build a formula which has h in the denominator. Yeah.
I have another question.
Yeah.
Why didn't you distribute x in the denominator?
You can, but somehow we don't do it usually. You can distribute it. It's not wrong, but it's extra step, which is usually not helpful, so we don't do it. Yeah, that's a good question too. Surprisingly, it's easier to have it in a factored way for some reason. Maybe because you can clearly see h separately like so, and it's just nice. So this is what we just did. That, and also you see we practiced some algebra. What I wanted to show when I was talking about this idea of changing h, this is what we're talking about. So when h is there, then this line is not moving. The line, I told you, it's every rate of change, it's there, it's fixed. But as a scientist, then I can start changing h. And just like in my example with the zebrafish, I want to make h smaller. In this case, they call it delta x. It is also common because it's on the x-axis, so why not call it delta x, changing x. So you see, I'm shrinking the right endpoint. I'm like, let's make step size smaller and smaller and smaller and smaller. The smaller I do, the better the result. That was very interesting. That's what we're doing. We kind of keep checking what is happening with different inputs and outputs. Let's do this example. One more example. Let's see if you can do it faster than me, because I think you can. Same thing, but different function. F of x is now 6x squared minus 5x plus 3. Let's find...
Wait, that's G or 6?
6. Yeah, thank you for asking. Never be afraid to ask about my handwriting. Did I tell you? I think I told my calculus 3 students. I always ask my students which x they prefer. Europeans have x looking like this. And then I ask my students, would you like me to do this x or this x? And Americans always choose the second one. And then I ask them, but if I do the second x, how do you cross it? Like so? Our x is kind of more beautiful to cross. So that's funny, but somehow you guys don't like the curly X here. I don't know why. So I stopped doing it. So I stopped doing it. And then also my students were complaining about my 9. My 9 are like these, because we don't have a G letter in Russian. So that's not a problem. And then here students are complaining that they don't see the difference. So I had to train myself, and it took me 2 years to finally make it like this. So it's like a whole learning process, you know. Find the difference quotient. Difference quotient. So we know the formula and now we know the steps. Solution. Step 1. Let's find f of x plus h. Let's see if you understood the idea with plugging love. So input is x, output is 6 times input squared minus 5 times input plus 3. If I plug love, it will be 6 love squared minus 5 love plus 3. If I plug x plus h, the same thing. You locate all the inputs and substitute them with any new input I told you to have. So what is going to be 6 times what? Squared. You see, you need to not only keep all the operations, like square in this case, but you also have to put parentheses to make sure you will distribute correctly in the future. Minus what?
5.
X plus h, put parentheses, that's very important. Plus what? 3, nothing more. Do you all understand? This is like really important. Surprisingly, copying and pasting things is like really important skill. Yes?
If we could simplify the original...
Yes, you can do it. You want to factor or something, yeah? Yeah, good question. Can we, this is correct equation. Can we factor and then do it? Yeah, you can do it, but it's kind of extra work and might not necessarily pay back. But it's a good point. Well, you can try and see if it's helpful. So let's simplify this. Step 1 is already troublemaking because that is a lot of work. Let's simplify this first. How would I simplify this first? 6x squared plus 6h squared, like so? Like what is the first term? Now that doesn't look good. So remember, you cannot just put squares on top. That is important. You need to use the formula. What kind of formula? 6, I will open parentheses. Formula called square of sum. The formula says square the first term plus double product plus square the second term. Remember that. That is also very important. Don't make this mistake. Hundreds of students made this mistake before you, and you should not do that mistake. You should be the one who will stop the cycle of this mistake. Minus 5x minus 5h. Remember to distribute both negative signs there. Plus 3. Do you all agree? That's see lecture 0. The formula is there. And also last time we used that formula as well. Now I'm going to distribute 6 everywhere. Everywhere, I see. 6x squared plus 12xh plus 6h squared. That was only the first part. Minus 5x minus 5h plus 3. Agree? Let me wait.
Do you actually put those in parentheses or that?
What?
Are the parentheses actually important?
No, I just do them specifically for teaching so you have visuals. But actually, I don't usually put it myself either. Those parentheses are not important. Just for visual, it was there. What do I cancel? Who sees the canceling part? You feel happy when you cancel or collect terms. What kind of terms? There's no squares for x and h, more than that. 12xh. Oh, bless you. Actually, that's all. We actually keep it as it is. I kind of hoped it will go away a little bit. Okay, so then we do step 2. F of x plus h minus the original f of x. Now the fun begins. So I'll put in green. I'll put in blue. Whatever we already found. 6x squared plus 12xh plus 6h squared minus 5x minus 5h plus 3. I just copied what we just did. And then in green color, I will put the original one. Minus, minus. A big mistake will be if you don't put the parentheses. This is very important. The original function was 6x squared minus 5x plus 3. That is the original. So I just copied it. Now I hope something will cancel out. Let's see. 6x squared and minus 6x squared goes away. You distribute a negative sign, remember? What else? Minus 5x and minus gives you plus. So that also, what's more? 3 and 3. So basically whatever you see copied in the parentheses, that should go away. So the whole second part goes away. We're only left with 12xh plus 6h squared. This is good news. Minus. Why minus? Oh, that one, I lost. This is good news. Why? Who knows why the next step will be pleasant? Because we're dividing by h. It's nice to see that we can factor out h. Because the third step will be, don't forget to divide by h. So it will be 12xh plus 6h squared minus 5h over the h, because it's the formula. That is the formula. So I cannot just divide things without factoring. That is not good. So let's factor h. H from the numerator. Factoring means dividing. See lecture 0. I did that before. 12x plus 6h minus 5. I'm just h without square. Yeah. 12xh becomes 12x. 6h squared becomes 6h. Minus 5h becomes just minus 5. Divided by h cancels out the h. And that is the answer. 12x plus 6h minus 5. It's much shorter. It includes h, which is a step size. And now I can change it the h as way I want, and this will give me the average rate of change for this quadratic function with this small step size, which is nice. If you can see in your homework, you will have to do the same thing with the square root, squares. So it's more about algebra than actually something new. Yes. So.